All right, atomic structure for the alkalis. The first group on the periodic table we'll talk about today, they are the soft metals. They are the metals. So let's look at the periodic table. And they're also rare. They don't like to be alone. You know, they want to be with people. They want to combine. They want to make compounds. So let's look at the periodic table. Here's a picture. All right, here they are. And this is not the full periodic table. As you can see up here, over here, we only have 14 up here, but there are 18 groups. But we're only concerned with the alkalis, which I'm circling now. Attempting to circle anyway, right here. So hydrogen, this is hydrogen. We don't count that as an alkali. So it's not part of the alkalis. So the alkalis are the first group, and they are soft metals. And then, like I said, they want to be alone. So they're rare on Earth. It's very rare to find them alone. They'll always be combined with other elements, and we'll get into that. So here you have, on the top, you have lithium, which you're probably familiar with when making car batteries, right? Those electric vehicles. We have our sodium right here. Here's our sodium, Na. K for potassium, which used to be called kalium, if you're interested. Actually, it may be called that in some countries still. Kalium, that is. And then we have rubidium right here. Here's rubidium, cesium, and francium. And by the way, but francium is the only one, it's the only one that is radioactive. Radioactive. Gives off the radiation, which is dangerous. We should know that, right? So let me write francium up here for you. Francium. It's the only one that is radioactive. It is the most reactive one. The most reactive alkali. I'll talk about that. So we have our sodium here. And by the way, with all these, again, like I said, it's very important to know that they're rare alone. So when you hear about sodium, and if you're looking at your food labels and it says sodium, they're actually talking about sodium chloride, which is it's just a mixture of an alkali and a halogen. And I'll go over that in this video. So here's a better view of our alkali metals. And make sure we have our pen ready. So like I said before, when you're thinking about sodium, they just say sodium on their food label, but they actually mean sodium with chlorine, and you make table salt. You get sodium chloride. And the same with all these other alkalis. When you're thinking about potassium in bananas, it's actually potassium citrate, which we'll go over again in the video also. Right, and so I mentioned radioactive and reactive. Let's make sure we know the difference over here. So if we say reactive, right, reactive is how easily it will combine, the element that is, will combine with other elements. And the alkalis are the most reactive metals, right? The alkalis, and they're soft metals, right, are the most reactive. The most reactive, they will combine with other elements better than any other metal. The most reactive metal. And the halogens, which we'll talk about in another video, are the most reactive gas. But you can see the alkalis and the halogens do combine a lot, and I'll show you that picture in a minute. So that's reactivity, right? We can say reactive, reactivity. And radioactive, I'm sure we know what radioactive. Radioactive elements are unstable. They give off radiation. The elements give off radiation, which can be very dangerous, right? So I said before that we had francium. Francium is the most reactive and the most radioactive. In fact, it's the only one. It's the only radioactive alkali. That's francium. So let's look at the picture again. Keep that up for a minute if you want to write that down. Or you can rewind the tape if you need to. Okay, so here we go. All right, so again, as you go down from the alkalis. The reactivity increases. I'll say it again. As you go down, see this arrow, as you go down, the reactivity increases. So sodium right here will be more reactive than lithium over here, right? Potassium will be more reactive over here than sodium, and so on, right? So that's why francium is more reactive. It's the most reactive alkali metal. And the halogen over here, it actually is doing the opposite. The reactivity increases as you go up. That's why fluorine is the most reactive halogen. And the alkalis love to combine with the halogens. So as again, we have sodium chloride, which is table salt. But the alkalis love to form salts. So there's other types of salt besides table salt. And also, let me just make sure that you understand this, that the alkalis are rare to be alone. They don't like to be alone. They want to combine with other elements. And francium, way down here, francium, it's very rare to see outside the lab. So again, with francium, it's the most reactive, and it is the most radioactive, and it is the only radioactive alkali. The next thing to know about alkalis is they react violently with water. So they react with other compounds, right? But they react violently with water. H2O, dihydrogen oxide. They react violently with water. So if you put sodium, for example, and I've done this in class outside, we've done this in the outside lab, you put sodium in water, it can cause a fire, cause a little flame, or it can cause a little spark. If you put enough sodium in, it can cause an explosion. Now, as I said, as you go down the list, you put potassium in water, it will react even more violently than sodium, and so on. So you can imagine if you put francium in water, can cause a very violent explosion. And when they react with water, they will release hydrogen gas. Now, if francium reacted with water, not only will you get the explosion, but you'll have radiation in the area. So highly unstable, highly violent. Is that such a word? Highly violent? So again, they react violently with water. They release hydrogen gas, and they can cause an explosion or a flame, depending on how much you're actually putting in the water. And here's the Bohr model of sodium. Now, all alkalis have one electron in their outer shell. This is their last shell, right? So here's the K shell, this is the L shell, the M shell. And I have talked about these in other videos, and I will talk about them more in other videos. So as you can see, in its last shell, it has one electron. And that last electron, or we say the last electrons in the last shell, are called valence electrons. The valence electrons. And all alkalis have one valence electron. Now I'm going to talk more about valence electrons because there's more to it than just having one in the outer shell. There's something I have to talk about in later videos about orbitals. But as you can see let me show you another picture. Right here's potassium. And you can see on their last shell, right over here, and let's make sure we have the pen ready. Here's their last shell. How many electrons are on their outer shell? One, because all alkalis have one. And what is that called again? What is that last electron? Or what are the electrons called they don't have to be just one. You can have electrons that have two, right? Like the alkali earth metals, which we'll talk about. So it's called valence electrons. And the alkalis again have how many valence? One, right there. All right. All right. Now, the next thing about the alkali earth metals, the alkalis, not the alkali earth metals, that's the next one. That's group 2. But another thing about the alkalis is they're soft, silvery metals. So they're soft. They're soft, and they have a silver tone to them, silver metals. They're not silver, by the way, a silver look. They have a silver look to them. Right? And since they're soft, you can cut them with a plastic knife. They're very easy to cut. And, we think of them, in our foods, and they are electrolytes. There are some, so potassium, for example, and sodium are electrolytes. Let's show a picture of these metals. So here's potassium. Now, again, this is not the potassium in your body. Potassium, like I said, with all alkalis, they have to combine with other. They don't have to, but they do. They combine with other elements. So the potassium in your body is potassium citrate. But there are electrolytes. So here it is. It's kind of silvery, and there are electrolytes. Potassium is an electrolyte, and you hear about these. You might be seeing ads for Gatorade, or you have to increase your electrolytes. By the way, your body makes its own electrolytes. But anyway, so you have potassium and sodium. They're all electrolytes, right? And again, electrolytes. Let's write electrolytes here. Electrolytes. They help. Right? I forgot the they. They help your body. They help your body regulate chemical reactions. Okay. So potassium and sodium of the alkalis are our electrolytes. And here's sodium. See, kind of looks like potassium, right? Put Na there. Get our pen going. Change it to green. There's our sodium. So when we mix sodium, we make compounds. I'm going to talk about compounds coming up in other videos, but it's the mixture of when we take sodium plus take chlorine, and we get sodium chloride, which is table salt. Talk table salt. Table salt. Okay, and it's just, we don't have to say table salt. Sodium chloride is the salt that we eat. There are other salts. All alkalis make salts. Let me write that over here, because the alkalis react vigorously with the halogens. So the alkalis, which we're talking about, the alkalis react vigorously, violently. Well, not, let's say vigorously, right? They react vigorously with the halogens. Like fluorine, for example, and chlorine. Those are and they produce, guess what? I just said it before. Salts. There's other salts besides table salt. For example, in your toothpaste, guess what you have in your toothpaste? Sodium fluoride, which is in toothpaste. So, toothpaste. Right? And that's a type of salt. And there's also others like potassium fluoride, which is used as a preservative, and there's potassium bromide that's used as a sedative. And I mentioned potassium citrate. Let's put it over here. Potassium citrate. Or citrate, however you want to pronounce it. That's, found in bananas, found in foods, potassium that we need for our blood pressure and so forth. All right, so we talked about the alkalis and the halogens I mentioned here, and the halogens are over here. Let's get our pen going. These are the halogens. The halogens are gas, right? They're in the gas state. Remember, the periodic table, as you go from the left to the right, you go from metals to gas. So the alkalis are the most reactive metals, and the halogens over here are the most reactive gas. The next video, though, we're going to be talking about the alkali earth metals, which are in group 2 over here. We'll talk about them next.